complete the table of ordered pairs for the equation of this line. Okay, so let's go over a quick review of lines. Remember, lines are graphed on a Cartesian plane, and for example, if we wanted to plot the points are ordered pairs where we have the x and the y, x first and then y. This would represent 3, so the x-axis is the horizontal axis, 3 to the right, and -2, 2 down. The y-axis is the vertical axis. So we write this as y. Our little arrows on the end of our axis. This is the x-axis. So the point 3, -2 would be right here. Okay, and remember quadrants: first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, quick review. All right. So what does this mean? Complete the table of ordered pairs. This means we have a table. These are some x's. These are some y's. Plug in this for x. Find out the y that goes with it. So if we plug in 0 for x, we can figure out the y that goes with 0. So this would be 0, -4y equals 12. Divide both sides by -4. Y equals -3. Okay, -3. So this is an ordered pair. 0, -3. 0, -3 is a point on the graph of this line. Let's go ahead and plug in 0 for y and see what we get. 3x minus 4 times 0 equals 12. So this part is 0, so it goes away. So 3x equals 12. Divide both sides by 3. X equals 4. So we know 4 goes right here. And so now we have the point 4, 0 as an ordered pair. It's a point on our graph. Okay, great. And these 2 points are actually special points. So let's go ahead and graph them real quick and see what they look like. So let me erase just enough for us to graph it. If we have our graph, this point 0, -3 is the point right here, and this point 4, 0 is the point right here. And so notice this point where x is 0 is a y-intercept, and this point where y is 0 is an x-intercept. And these 2 points are particularly special because they are intercepts. But if we connect the dots, if we have 2 points and connect them, then we have the graph of our line. Alright, awesome. Let's move on to the next one. Sorry, we can move on. Okay. So, this is the equation for a line. It's called standard form. Okay, so there are several forms for lines. This particular one, ax plus by, is called equals c, is called standard form, and a, b, and c are all constants. Okay, look at the equation of this line. 2x minus y equals 4. Is this in standard form? And if it is, what's a, what's b, and what's c? Okay, a would be 2. This is the coefficient attached to the x. B would be -1. It's the coefficient attached to the y. Remember there's a 1 here that we don't write. And c, the constant term, would be 4. Okay, great. And it says find the x and the y intercepts and graph. How do we find x and y x-intercept? We let y be 0. Okay, let y equal 0 to find the x-intercept. So we plug in 0 for y. Okay, and solve. 2x equals 4. X equals 2. And so we get the point, 2, 0. And if we want to find a y-intercept, we let x equal 0. Okay, so we get 2 times 0 minus y equals 4. So minus y equals 4, y equals -4. Okay, so we get the point 0, -4 for a y-intercept. Then once we get those 2 points, we can graph it. 2, 0 is the x-intercept. 0, negative 4 is the y-intercept. And then we can connect those points. And that's the graph of our line. Okay, what about this? Y equals 3. Okay, if we go to the y-axis, where does it equal 3? Right here. Okay, and then the equation of our line is going to be a horizontal line right at 3. So it looks like this. Okay, what about x plus 2 equals 0? Well, if we subtract 2 from both sides, we get x equals negative 2. So if we go to negative 2 on the x-axis, it's right here, and x equals negative 2 all along this vertical. Okay, so this is our graph. Okay, so we get this vertical line right here. Alright, what about this? Graph the line that passes through this point. It might be best in this case to make a table of some x's and some y's. You can pick which x's you want or which y's. I'm going to go ahead and pick negative 1, 0, and 1 for x, and then I'm going to find the y's that go with them. If we plug in negative 1, we get 3 times negative 1 equals minus y equals 0. I'm going to go ahead and subtract y from both sides. So, add y. Add y to both sides, and you get this, 3x equals y. And this equation is going to be a little bit easier to work with. So that's what I did. I plugged in negative 1 right there. So this means 3 is y. So in the first case, we get 3. Second case, negative 3 times 0 equals y. Okay. Here, we just get 0. And third case, we have negative 3 times 1 equals y. So that is negative 3. So let's go ahead and plot those points. Negative 1, 3, negative 1, 3, 0, 0, 3, negative 1. Oops, sorry. 1, negative 3. There we go. Now I have a straight line. Connect the dots. That is the graph of our line. Okay, midpoint formula. If a midpoint, if the endpoints of a line segment PQ are x1, y1, and x2, y2, its midpoint is this formula. Now, I want to remember this, write this down. It will pop up again later. Let's use this formula to find the midpoint of these 2 points. So remember, it was x1 plus x2 over 2, comma, y1 plus y2 over 2. Let's plug them in. This will be our x1, y1. This will be our x2, y2. Now what happens if we switch these? That's okay, so long as x2, y2 go together and x1, y1 go together. So if this were x2, y2, and this were x1, y1, that would be okay. Okay, let's plug them into this formula. x1 is negative 5 plus x2 is 2 over 2. y1 is 8 plus y2 is 4 over 2. So we get negative 3 over 2 and 12 over 2. And so this gives us the ordered pair, negative 3 over 2, 6. And this would be the midpoint between these 2 points. If we graph it, we can see negative 5, 8, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. This point is about right here. And then the second point is 2, 4, 1, 2, 1, 2, 3, 4. It's about right here. And if we plot this point, negative 3 halves is about negative 1 1/2, 6, 1, 2, 3, 4, 5, 6. It's about right here-ish. This would be the midpoint, halfway between the 2 points. Great.